Hello everyone, I am Ramesh KS. So welcome to the class. In this session, we will discuss about memory representation of a queue using linked list. So it will be asked for 3 marks, the diagram 2 marks and the explanation 1 mark. See, observe, it is very easy explanation. Let us concentrate. All of you know that earlier classes we discussed the linked list. This is the example for linked list. So queues are also represented using linked list. So queues, these are the elements which are in the nodes, which is available in the nodes. These are the nodes. 50 are available in this, and 20 is available in this, 25 in this. This is front end and rear end. Queue contains two ends, right? This is front end and this is rear end. Last end is called rear end, the first end is called front end. So in queues, an item should be inserted from rear end. Always the items will be inserted from this end, not this end. Okay, na? It will be inserted from this end only. And an item should be removed. It will not be removed from here. It will go here, from here to here. It will go here. So if we want to remove an item, this item will be removed in queue, not in stack. So the pointer front contains, this is front contains the location of the first node. This is the location. Suppose 0, assume 0 is the location. This is the first location of the node. Linked list, this is the first node. And another pointer rear contains the location of the last node. This is the location of the last node. This is the location of the first node. This is the location of the last node. Suppose I am inserting a new item into this queue. It will be added here, rear end of the queue. Suppose I am removing this front element from this linked list. If I remove this element only, we are removing. See, after removing of 50, this is the linked list. After inserting of the new element into this linked list, this is the diagram. This is the memory representation of a queue is a linked list. So please note down and write this and practice it. Okay. Let us move on. Algorithm for insertion. So this is what insertion. Inserting an element into a queue. Suppose they will ask you a question like this. They may ask you the question like this. Write an algorithm. Write an algorithm to insert into an element into rear end of the queue. Insert an element into rear end of the queue. So this is the question. So if they ask you, we have to write this algorithm. This is very interesting algorithm. Please concentrate. So rear is equal to n minus 1. Rear value is n minus 1. Then print overflow. Suppose I am taking this is a queue. Okay. This is a queue. So queue having elements. This is what front end. Let us assume this is front end. This is, I am taking rear end. This is rear end. Okay. I am taking here the elements the positions. First of all, I will take the positions here: 0 position, first position, second position, and also I am taking some values in this. I am taking 2, 3, 4. Okay. Now in this example, rare is what? How many elements are in this? N is how much? N is 3. N minus 1. N minus 1 is 3 minus 1. That is 2. Okay. 2. So the rare is what? Rare is 2 here. Rare is 2. This is rare. Okay, na? So now 2 is matched with n minus 1. N minus 1 is 2. So 2 equal to 2 becomes what? True, right? So if it is true, what we are printing? Print overflow. That means this queue is full. Queue is full or overflow. We cannot insert an element into this queue because there is no space to insert an element into this queue. That's why we are writing this condition. Okay. Now we are moving into step 2. I am taking another queue. I am taking another queue. Let us take here. Okay. This is one queue. This queue contains elements. I am taking here. Let us take. I am taking here 2, 3 only. I am not accommodating this position, this memory cell. Okay, na? I am not accommodating it. So I am taking the positions here. This is the 0th position. This is first position. This is second position. Okay. Now this is a queue. All of you know this. This is a front end. This is a front end. This is front end. Front end. This is rear end. Okay. So generally we are taking this is as a rear end. This is as a rear end. Okay, na? So let us concentrate step 2. Front is equal to null. Front is equal to null. If it is null, suppose I am taking another example for this. For this case, this is step 3 I am discussing. Next I will discuss this step 3. Now I will discuss step 2 now. Okay. So this is what a queue which does not contain any value. That means front is null, not 0. Front is null. If there is no value into this, front is null. So if the front is null, null equal to null, which becomes true. So once if it is true, we are making front as 0 and rear as 0. So this is 0. I am making. This is front element. This is front. Okay. So now after making front as 0, so we can able to insert the data into this. Okay. So now I wanted to insert an element into this. You can insert the item. Suppose it is like 30. This is an item. This item we can insert into this rear end of the queue first. Queue of rear. Queue of rear in this example, this is this one only, not this one. Front and rear both are 0, right? So that is rear also 0. Here this 30 element I am moving into this place. So it will execute first and further it will execute step 3. This is the second case. Okay, na? So moving on, the third case I am discussing, this case. Now in this case the step 1 will not execute, step 2 also will not execute, because rear is equal to n minus 1 becomes false, it will move to step 2. Again it becomes false, it will move to else. So rear is equal to rear plus 1. Now rear is this one. Now rear is this one. That means rear is 1. So rear plus 1 is 2. Now 2 becomes rear plus 1. Rear plus 1 value we are moving into rear. So rear value how much? 2. 2, right? So 2. Now Q of rear means what? This position. This area is called Q of rear. So what item I am going to move? 30 item I am going to move into this place. So 30 will be moved here in this rear end. So this is the third case. Okay, all of you understood, right? The first case is this one, the second case is this one. You can insert the value here, 30, the second case, and third case is this one. This is inserting an algorithm into a rear end of the queue. Okay. So now we will discuss algorithm for deletion. That means they may ask you the question like this. They may ask you the question like this. Write an algorithm. Write an algorithm to delete an element from the queue. This is the algorithm. So now you tell me, we discussed this insert algorithm, right? So the same as it is, but some few changes is there in this. So I am taking one queue. This is queue. This is queue. So in this queue it contains 0, 1, 2. This is the elements 2, 3, 4. So this is which one? This is front end. This is rear end. This is front end and rear end. So in this, which element I am going to remove? This 2 element, because front element can be removed first. Front is equal to null. Front is not null. We are not executing this step. Now we are executing step 2 now. Item is equal to Q of front. First we are identifying which element we are going to remove. Front is how much? 0. Q of front means 2. This is Q of front. Q of front means 2. So item is what? 2 now. So that means this element I am going to remove. That is the step 2. Which element I am going to remove? That element is 2 element is we are removing here. Now we are moving into step 3 now. Front is equal to rear, then if Q has only one element, here not more than one element, this step 3 will not execute. Where it will go? It will go else. Front is equal to front plus 1. Front is equal to front plus 1. If it has more than one element, it will execute. So after removing this 2, this 3 will come here. It become front. Otherwise 0 at the 0th position to 1th position, the front value will move. This will be removed. It is moving. Otherwise this front will be assigned to this one because it will be removed, right? That's why. This is the case. Okay. Now I am taking another approach. If the queue contains no elements, empty, this is empty, okay, empty queue. So now front is what? Null, right? So print is underflow. Queue is empty, that means it is empty. So empty queue, the elements are not there. So if the elements are not there, we cannot remove. So this is the second case. Third case, last case I am discussing now. Suppose this is a queue. This is the queue. In this queue, I am taking some value in this 3. Let us assume 3. Single element. Okay, na? 3. So front is equal to null. In this front is null, na? Front is null, no. Front having value 0. Front is not null, 0. 0 equal to null becomes false. This will not execute. So we are identifying the element. 3 element we are going to remove. We identified item as 3 now. Now again we are executing step 3. If front is equal to rear, yes, front is 0, rear also 0. So front is equal to rear, then front becomes null. So once if you remove this, what happens? It becomes like this. So front becomes null and rear becomes null. So these are 3 cases we are discussing now. Thank you everyone.